Sarah Doss left for her first trip to Antarctica right after college.
I didn't really know what to do with my life, as I think many people who are finishing college can relate to that feeling. And I had the opportunity to be part of a research team from Caltech that was working in the middle of West Antarctica. We would spend 3 months in this small remote tent camp. I had no idea what to expect, but I was game for whatever.
After a stopover in New Zealand, she got on a plane bound for the ice sheet.
Everything about it felt unusual, right? I considered myself fairly well-traveled, but really nothing prepares you for being on a 6 or 8 hour flight from New Zealand, and you just cross the Southern Ocean. You're looking out these tiny windows. We're on military aircraft, and all of a sudden you see the edge of the sea ice, and you think, oh, we're almost there. And then it's just like more and more ice, and you just start to feel like you're on an alien planet.
She landed at the main U.S. research station in Antarctica, where the team did some final prep before moving on to their camp.
And they open the doors and you step out and you're just shocked with the dry and the cold and the intensity of it. You could have convinced me that I had traveled into outer space, into some other world entirely. I was glad I could still breathe. I'll never forget that experience of traveling to the Antarctic for the first time.
Welcome to Ask MIT Climate. I'm Madison Goldberg. The frozen parts of our planet, from mountain glaciers to floating sea ice to the sprawling polar ice sheets, are facing profound risks from climate change. Already, a warmer world has transformed these landscapes with consequences that span the whole Earth. Dr. Doss, who's a Scientist Emeritus at Woods Hole Oceanographic Institution, has done decades of research on 2 very big pieces of this system.
I like to refer to myself as a polar glaciologist, which is a bit of a mouthful. Essentially, I've spent my career studying and trying to understand the big ice sheets on planet Earth. So that's the Greenland ice sheet in the north and the Antarctic ice sheet in the south.
In today's episode, Dr. Doss is going to bring us up to speed on the state of those ice sheets, and she'll tell us about her experiences learning how they work. She'll also help us understand how changes in the polar regions, sea ice that's getting sparser, melting ice sheets that raise global sea level, affect people's lives now and in the future. Okay, first off, let's get a sense of scale.
So Antarctica is a big place, right? It's covered by this vast ice sheet, thousands of kilometers across in all directions.
Together, the huge expanses of ice that blanket Antarctica and Greenland cover around 6 million square miles, which is close to the size of Russia. The ice is also extremely deep. At its thickest point, the Antarctic ice sheet goes down literally for miles. One thing to know about ice sheets, Dr. Doss says, is that they're not static. Ice is always flowing out from the center toward the ocean. The ice sheet loses mass through processes like meltwater running into the sea and icebergs breaking off. But as long as it gains ice at roughly the same pace, it's not shrinking. In other words, it's more or less in a state of balance. Right now, though, our planet's ice sheets are very much unbalanced.
Both Antarctic ice sheet and Greenland ice sheet now are losing mass and shrinking. That's really the bottom line.
There are a few ways to measure the amount of ice being lost. One strategy that's pretty cool is called gravimetry.
It turns out you actually can weigh the Antarctic ice sheet. The pair of satellites, as they pass over a big mass like the Antarctic ice sheet, they're responding to the gravitational pull of that ice, right? You can use these subtle differences in the distance between the 2 satellites to help you understand how big Antarctica is and what that gravitational pull is.
The ice sheet's gravitational pulls are weakening because they're losing a lot of ice. Since 2002, an average of 400 billion metric tons a year. Just to paint you a picture, if you spread 400 billion tons of water across Texas, it would cover the state to a depth of almost 2 feet. Warming near the poles causes a lot of other changes besides this heaping addition of water to the ocean, especially in the Arctic, which is heating up much faster than the global average. Arctic sea ice has gotten thinner and covers less area. Consistently frozen ground in the region, known as permafrost, is warming. Wildfires are getting bigger and more frequent. And all these changes are affecting people's lives.
So one of the things that makes the Arctic region very special and sort of foundational for people who live there is the fact that there is ice in all sorts of different forms. So not just the glacier ice or big Greenland ice sheet, but you have sea ice, you have icebergs, you have snow. And so communities have adapted very well to how do they live, how do they move, how do they sustain themselves economically and food and things like that, working with the ice, right, sort of hand in hand. And as the Arctic has been warming, a lot of these patterns and systems are being disrupted very quickly.
Many indigenous communities in the Arctic are experiencing and working to respond to especially disruptive changes. For example, Inupiaq people in northern Alaska have seen changes in sea ice reshape the seal hunting season. And in parts of northern Canada, floating ice is crucial for travel, which is becoming less safe as conditions shift.
As the seasons have been changing and the Arctic's been warming, the sea ice often is now not forming at the same time or in the same places, or it's not as strong.
Changes like these can affect whether and how people can access deeply important foods and practices. Another challenge is thawing permafrost, which is causing structural problems.
Communities have been built on frozen ground for generations, and now as the Arctic warms, this frozen ground is thawing and it's sliding and slumping.
In Alaska, Canada, and Russia, this unstable ground has led to slanting houses, damaged water pipes, and cracking roads. There are many ways of observing and understanding our planet's poles as they undergo these profound transformations. There are those satellites that measure the weakening pull of the ice sheets, plus others that gauge their height and the speed of ice as it flows to the ocean. Indigenous communities are documenting changes in sea ice and coastal storms based on knowledge about the Arctic built over generations. Fieldwork in Antarctica has monitored animals like seals and penguins. In her work, Dr. Doss has spent a lot of time observing and gathering data on how ice moves, which is crucial to understand. Remember the 400 billion tons of water that ice sheets are shedding into the ocean every year? Well, there's plenty more where that came from.
There is so much ice that is locked up in the Antarctic and Greenland ice sheets that is the equivalent of tens of meters of sea level rise. And going forward, we have to think about, as these ice sheets are shrinking, how much of that ice is going into the ocean, how quickly.
Right. Scientists have to understand the flow of this ice in order to estimate how much of it will get dumped into the ocean this century and beyond, and therefore how we can expect sea level to rise as a result of the shrinking ice sheets. The sea level rise we've already seen has meant worse damage from hurricanes and more flooding at high tide for people who live near the world's coastlines. But the impacts are on track to get worse. How much worse depends in large part on us and whether we take steps to curb our climate pollution. It also depends on how the ice sheets respond to warming now and in the future. And this is where Dr. Doss's research comes in. One goal of her work has been to help us hone our expectations of ice sheets' behavior in the decades and centuries to come.
So in particular, on the edges of the Greenland ice sheet, we've spent over 2 decades in certain areas trying to understand how meltwater moves around on the surface, how it gets through the ice to the bottom of the ice sheet, and how that impacts the ice movement all the way out to the sea. One of the projects that I've spent a lot of time working on in Greenland is in this melt zone on the west coast, where we're studying these huge lakes that form every season when the ice melts. And these lakes are kilometers across, and they just hold enormous volumes of meltwater. And one of the things that our team discovered is the mechanism how these lakes actually, after they fill, many of them drain instantaneously by cracking a hole through the ice sheet all the way down below, through this 1,000 meters of cold ice.
Research by Dr. Doss and her team suggests that when these lakes drain suddenly, the outpouring of water can temporarily speed up the flow of ice to the ocean. These events are also incredible to witness, as her group learned when they were camped out next to a lake right as it started to drain.
There were maybe 5 or 6 of us, and we just kind of looked at each other almost in panic, right? And you could hear this cracking and creaking and rushing of water sound. And here's this lake cracking open, this glacier and pouring water that exceeds the rate of Niagara Falls down 1,000 meters of ice, like right outside our tent. So we put our crampons on and our ice axes and we go marching to the edge of the lake. And because it's a foggy day, you have to get really up close to it before you sort of start to see the water line receding and the ice that had been covered with this like deep blue water just gone. But one thing we realized just by being there that we never would have observed in any other way is that while all this was happening, there were these tiny micro cracks that were just like spreading out like cobwebs everywhere, including under our feet. That is a feeling that's just incredible. And I've never had that happen again.
Dr. Doss and others do all this work in order to get a better understanding of the ice sheet's current and future behavior. And there are still plenty of urgent questions about how they'll respond in a world that continues to warm.
One of the most important questions in the field of glaciology right now has to do with the behavior of these large glaciers in West Antarctica, Pine Island and Thwaites, that are in the news a lot.
West Antarctica is the part of the ice sheet that's seen the most mass loss in recent decades. And it's a region that scientists remain really concerned about for the future. A big part of this worry revolves around West Antarctic ice that rests on land below the waterline and which slopes down toward the interior. That could put these parts of the ice sheet in danger of a runaway process. Basically, it starts when ice on land loses support from big, floating ice shelves, which are currently being eaten away by warm ocean water, and glaciers start to retreat inward. The idea here is that thanks to the geometry of the land, that retreat keeps itself going, not stopping until the ice shelves regrow or the glacier reaches an upward slope, even if we halt the warming that kicked it off in the first place.
And West Antarctica has the potential to raise global sea level by a few meters, so it's big by itself, right?
Scientists are working hard to better understand this instability, including whether or not it's already begun in the most vulnerable areas, and what the process might mean for future sea level rise. A lot of the stuff we covered today can feel mind-bogglingly big. We're talking about massive amounts of ice being lost from even more massive ice sheets, entering an ocean that sprawls over the face of the planet. We're trying to think about what the world will be like 50, 100, 200 years from now. And Dr. Doss gets that all this can feel overwhelming. But she says just because there are still big and complex questions doesn't mean we have no say over the future. For instance, over how sea level rise will unfold.
Often when people think about sea level rise, it's couched in these terms of like, what will the number be? And then there's these uncertainty bands associated with it.
Like, there are big differences between the best case and worst case scenarios for sea level rise over this century and the next one and the next.
And that sort of feels impossible, right? What do you do with that information? And so one thing I think can be helpful in thinking about future sea level rise is really understanding that the ice is going to be melting, the oceans are going to continue expanding. And so rather than fixating on a point in time, there will be a foot of sea level rise at some point. There will be 2 feet. But if we can move that time frame out further and further, rather than closer and closer, which is what we're doing now, we buy ourselves so much time to adapt and some places to relocate or to design ways to live in peace with water. If we can start to think about future generations and buying them time and what a livable world looks like, I think we'll all be better off.
Ask MIT Climate is the climate change podcast of the Massachusetts Institute of Technology. Erin Krol is our executive producer. David Lishansky is our sound editor and producer. Michelle Harris fact-checks our episodes, and the music is by Blue Dot Sessions. I'm your host and associate producer, Madison Goldberg, and I also wrote today's episode. Thank you to Dr. Sarah Doss for speaking with us and to you for listening. Check out climate.mit.edu for more Ask MIT Climate, and find our videos on TikTok, Instagram, and YouTube at Ask MIT Climate. And we love hearing from listeners. If there's a climate question that's making your brain melt, send it to us at askmitclimate@mit.edu.